Hi there. Can you hear me? Everyone hear me? Thumbs up. Thumbs up. Great. Thanks, Jaden. Thanks. Was that Nicole? So my name's Mr. Dean or Dean. I am I teach Scratch for the spelling bee company here. And this is I've taught the course now probably five, the first one 4 or 5 times, and then there's a second level as well. I'll show you. I'll load up my presentation here and we'll get started once I've got 2 to go. So you're going to hear a lot from me in the next hour here. Okay, so Scratch. I need to share my screen. We are going to do this Scratch unit. There we go. So we have some students here that have already gone through this as well and are in our Scratch club. I'll talk about that more in a second. So I like to talk about Scratch and programming. Programming sounds a little complicated, but it's really what we do in Scratch is creative computing. Scratch is such a good beginner language to learn because it has aspects of it's an object-oriented programming language, which is what Java and C# and all these languages we use nowadays are. So if my thing works, there we go. It's laggy. There we go. Okay, who am I? Have a bachelor's degree in music, and I'm also from University of Toronto, and I'm also finishing my Bachelor of Education from the University of Ottawa. I taught last year in a grade 5 class of 30 students, and hopefully we'll be teaching this year if everything pans out. And I've spent more than 5 years working in digital media, so graphic design and video. And in my early university years, I released a few of my own with a friend, mobile games on the App Store, and that was like 10 years ago. So they're not up there anymore, but they were. It was quite the experience. So I will show you sort of what we do. Scratch is awesome because it has this classroom system. I've also looked at Microbit by Microsoft, and you can use Scratch to program those. It has its own block programming language, which will make sense in a second. But I think Scratch is the better option because we're not programming a little LED thing. They're both valuable. We're programming with graphics, and we can do a lot more. So we'll make a classroom account. And first lesson, we'll learn the interface. I'll show you where to find everything. Everything's color coded. There's multiple ways of doing things, and it's all represented by blocks. So it's like Lego. Instead of typing, I have a bunch of books here from the old times. These are like the 70s and the 80s. And these are kind of some things I learned to program BASIC in. And nowadays, instead of having to type in hundreds of lines of code and numbers, we can drag blocks and connect them like Lego blocks. And they have tons of potential to make cool things. So the other neat thing we can do is why Scratch is so good for learning is it's sort of an open education platform where anything anyone has made on Scratch, you can look at how they made it. You can load up their project and see inside. You can even copy it and make your own version of it. It's very good for learning because if you need to learn how to do something, you can search it up and find an example of it, and you can find 3 or 4 different ways of how things were done. For example, I asked the students in the Scratch Club, which is after you've taken 1 and 2, you can sign up for the Scratch Club. I asked them to make Snake, and Snake's a very simple game, but not very simple. It looks simple, but there's actually some complicated things going on. And there's multiple ways of having the snake follow itself. So you could track corners. You could add each corner to a list every time you move. You could use clones to follow behind the one that was in front of it. You can draw it with a pen tool. So there's multiple ways of doing things. That's a little more down the line. So then we learned the other thing that Scratch is really good for. It's similar to something like Macromedia. Oh, sorry, I'm aging myself. Adobe Flash, which is an animation tool. and I think it might be called Adobe Animate now, but it used to be called Macromedia Flash. And it was also had a programming scripting language called ActionScript. But what you can do is you can load in pictures and load in backgrounds and make them say things. You can use text to speech to have it actually talk in a friendly robotic voice. I gotta load up chat here. You know that binary is translated into words. Yes, we talked about that yesterday. You made a game in Scratch. Great. So some of these lessons are a little off now because I've added some more and changed and condensed some things. But we do an animate your name activity to learn about the different graphical effects and movement effects we can do to things, and then we learn about rotations and scale. So all of these things that we're learning are now. This last time I made this presentation, this wasn't in our Ontario curriculum yet, the programming, but now there is programming in the Ontario curriculum, and everything, if you take this course, you'll do everything up to even what they ask you to do in grade 8. Some of my activities, the programming curriculum that they want you to do is very simple so far. So you'll be well prepared for anything they throw at you in elementary school in Ontario, if you're in Ontario. So other things, this relates to geometry, and we'll do some language stuff too. Music, my first degree is in music, so we have one class dedicated to all the amazing things you can do with the music extensions. We'll make a song. I'll lead you through the notes to punch in, how to program them. And there's extensions you can add to Scratch to make it to give it more tools and things like that. So that's what this one's exploring. I have to correct the presentation before me there, the introduction. We don't do 3D printing. I have a quick little lesson on how to import graphics from outside sources. So the Paint 3D is not available to everyone. It's a Windows program. It's free, but I have this lesson here showing how we can take free models and rotate them and use them as backgrounds and sprites. But you have to do that on a Windows computer. So I demo this quickly, but then there's other sites like Spriter's Resource, which has all 2D graphics, and everyone can access those. I see a hand up. Can you use the drawing ability? We do a lot of drawing, and there's a lot of pre-made assets, is what we call them, it's a lot of fun. Sometimes I'll show you the final project, which I've done like 4 times with the groups now, and for one of them, and I just randomly press I build it with whatever I get randomly. There's some fun, creative options. We talk about the different types of graphics that you would encounter. So rasterized versus vector. Some of you may have heard of .png files or .svg files. These are 2 types of graphics formats, file types. One being bitmapped based or rasterized, and one being vector. So a lot of this course is me giving you dialogue to learn how to use things in the future, like Adobe Premiere for making videos or Photoshop. So a lot of the skills that I teach you, I use daily in those programs. So that's why Scratch is amazing. Wow, we're only halfway through this. So then we get a little bit into how we can describe the location of things in Scratch. We use the Cartesian plane, and we have a lesson on that where we compare the location of houses and to the plane as addresses. So there's a quick activity I made where figure out where envelope 1 is, figure out where envelope 3 is. So this is a fun one. That's one day. This is our first sort of intro, the code breaker. I have it as lesson 7, but it's probably earlier now. And it is where I introduce you to conditions. And this, I believe, is grade 3-4 is where you learn this now. But just the the concept of it. But in Scratch, we will learn in this course, you'll really understand it by the end of it. So if then statements, variables, and operators, all of these things we use to help our computer make decisions. And we make this code breaker activity that I can show you right here. And so what this is kind of a simulation. Oh, I'm cheating. I have you don't have these numbers when you first see it. We hide these numbers so our user doesn't know. But we randomly generate basically a lock combination, but we give our user a clue. So if I click this number, it should, if it was working, was working. Maybe this is another version of it. I've made so many versions of it. It's not doing what it should. Okay, well, it has worked the other 5 times. I gotta work on that one. Locked inside July. It's an old version, that's why. So I have tons and tons of projects here locked inside J8. Let's use this one. I think I was adding buttons. That's what I was doing. So as you see, this button went orange. That means we have a clue that at least one of these numbers is right. I based this on an old board game called Mastermind. So I know that's 2. Well, I can flip through this now. Oh, I know that's 4. And I know that this one's going to be 8. So if I bring this back to 2 and 4, it goes, my light will change green. We have cracked the combination. And on the inside, it's lots of ifs and greater thans and ands and ors. And if this is all gibberish to you, take this course and you'll understand it, because this is how we get computers to make decisions. And I've been using the metaphor of chocolate milk to describe this, which is how do you make to describe ands. As you see here, I have a repeat until digit 1 equals number 1, and digit 2, and digit 3. How do you make chocolate milk? If you have chocolate and milk, you don't have a glass, so you got a puddle on the floor. If you have a glass and milk, you only have milk. But if you have chocolate and a glass and milk, you have chocolate milk. So there's 3 things there's 3 conditions that have to be satisfied. So we learn a lot about this random number generation. Next, we get into making our final project, which I will show you one iteration of it. And so we start learning about how to do movement and collisions, and how to tell collisions, or if our sprites are hitting each other, if it has entered an area, if they have connected or collided. So we start doing that. And we do some more advanced movement in Scratch 2 afterwards. And then we do win-loss conditions, and we do a menu. And by the end, you'll have a full game, such as this one, Dangerous Dive. So we finish one full project, and we make a bunch of smaller projects. And this is a fairly standard. I've added a little bit to it, but you're a scuba diver, and there's fish that come at you, and you can throw spears back at the fish and get points. And if you get hit 3 times, it says game over. So we learn how to do a lot of this. There's some complicated stuff going on with the fish that are going up and down. That's called a sine wave. But I will walk you through all that math stuff, and you'll be fine. So that's the end of Scratch 1. And then we have Scratch 2, where we get into some of the more complicated, other powerful tools of Scratch. So we can make our own functions, or classes. What is happening to my presentation? There we go. Okay, we're going to scroll back down. I am going to show this. So we talk about vectors, and we start to do a little sort of physics programming. So with velocity, we can make our characters move smoothly. Like I've done here, my scuba diver slides and slows down. So this uses velocity rather than just jolting up and down. There's a place for everything, and there's things we can do to make games more smooth and easier to use. I can't get up to my program. There we go. So we do that. We talk about different types of variables. We talk about, we get more into animation. I also lead you through a ton of graphic design stuff from my experience. And then we get into this pen tool, which we can use to draw things like health bars and speedometers and power meters and logos. and we can use this to do a lot of things. We also use we make our own functions, which is you basically making your own commands, making our own blocks, like we see here on the side. These are all these pre-made blocks by Scratch, and I can drag them out. But I can also make my own set of commands, which allows us to do repetitive tasks a lot simpler. So yeah, so there's that. In Scratch 2, we do a bunch of projects. One time we did this artillery project. So this involves power and angles and gravity. And then we use particles. We make a particle system with clones in the Ghost effect. And the last time I taught this, we did a lander project. So we same sort of things apply: gravity, angles, power. And in this one, you control a spaceship, and you have to get to the green platform. And the fun thing about this iteration was when I taught this to this group of students, by the end, we had all the students make their own levels. They were simple like this. Some of them had some different graphics in the blue. But once we had 4 or 5 levels, one made by all the students and some by me, we had a game with multiple levels, and we could put them all in together. So that teaches group work, level design, and it was really fun to make something like that. And then we get into lists. So I show you how to make a tile engine. I show you, I talk about things you can do with lists like inventory and why we would use lists over a normal variable. So what do you want to make? After these classes, there's also Scratch Club. And Scratch Club is basically a session with me each week where you get to work on what you want to work, or a suggestion by myself, and you can, and I'm there to help you figure out how to program it. So I want to show you really quickly some projects that the students have made. One student has made, and she hasn't shown me this version yet. I asked her to do to add something this week, but this is sort of like if you've ever seen or played the game Roblox, there's a fashion contest where you get to pick clothes, and she's made it here so when you click the buttons, all the objects of our character come out, and it's not cycling through things yet, but if I press done, a certain light show happens. So she's working on this. But what kind of real uses does this have in the real world? Well, right now, when we're all stuck at home, some companies have built augmented reality applications for you to use your phone and cycle through shirts and pants and things, accessories that like sunglasses that you may want to purchase. So this is basically a demo of that. Well, what shirt do I want to wear? What pants do I want to wear? So there's a real world application of that. And let's look at another one. I've made this group project that we can all add to. It's sort of a Zelda-like dungeon adventure. I still have to do the animation. I'm taking care of most of the back end stuff. But when we go into doors, it loads another room. I got to make that prettier. And there can be enemies in the room, which there may be some over here. May load some enemies, a cute little bear and a centaur. So this is sort of more complicated stuff that we get to work on together in Scratch Club. So that's 3 different courses that I teach. And any questions about that? Do we want to do a Scratch thing together? Do you want me to show you more objects, or how am I doing for time? Why?
You have till 6:55, so you can either show more projects, or it's really up to you. Yeah.
Okay. Okay.
5 more minutes.
5 more minutes. Any questions in chat? What else do we have? The scuba game, let me load up my projects here. So I have a ton.
On the tank game.
The tank game. I made that. Is that you, Sam?
Yeah.
I made that with your class, right? We made that. Where is that? There's a bunch of tank games. I've made too many projects. Oh, I guess I could cycle it by class, sort it by class. Let's go through all of my projects to tank project. Hopefully this is the one. Only two views, so this might not be the one. Okay, so this one's really cool because we used the pen tool did I use WASD? This may not be the right one. Let me look inside. This one basically, this was just my demonstration, I think, of drawing randomized land. So here's an example of how we used my blocks. I made my own command called draw land. And then I used the pen tool to take this. This is a Scratch 2 thing, but it's pretty cool. To take this line basically that I've drawn, if I add some purple to it or something, you'll see what that does. And basically, it randomly stamps this line across my screen. So now if I press play, I added some purple, and it'll be a different terrain, and it's got purple in it. The purple, so it looks a little different. Why would we want to use this? Because we can create a different level each time. It's called procedural generation, and we can add things. We can chip away at this land in this tank game once I find the right version of it. So yeah, that's one thing I wish Scratch could add, is more folders to for myself to organize things, because I'm gonna admit you. And what else have we done? So here's an example of Snake. If you don't know what Snake is, it's a classic game. This demo has used the draw tool to draw their name, Cutie Poochie, and some cool animation for their name. But as you can see, we start with this cute little snake, and every time I get an apple, it gets longer. And by the end of the game, your snake is very long. And this is where I was talking about how there's usually 3 or 4 ways of programming something, and some are better than others, and some, I went really fast with the watermelon. So we can look inside this project, click see inside. I can find the snake, snake. They've made a sprite for that. We can change the costume if we want. Once it's a draw tool, so we would have to do that a different way with the pen here. If I want to change the color of the snake, which may break things, I have to go through here until I find a draw or a change color too. But this is a detailed project, draw snake. So they've made a draw snake command. I just have to find draw snake. So we learn to look at this stuff and understand what is going on here, and lots of stuff like that. Cool. What else? There's a graph. There's some graphic design stuff. This is one we just made in Scratch 1, and this was with iPad controls. You can do this Scratch 1 if you have an iPad and you don't have a computer. So we had to program in these controls so that our player on the iPad could press something, because the iPad doesn't have arrow keys. The iPad doesn't have a space bar. So we accommodated different devices and made it accessible to other uses.